well, welcome back to Black Swan Outdoors, and today we're going to be talking about how to use your WNDSN telemeter for land navigation. We've done a previous video on this specific model, which is the military model, the MIL model, in previous videos. So we've talked a little bit about its features and uses. So check that video out if you haven't seen that already. And some of the things that we're going to be talking about in terms of navigation are topics that we covered in previous videos. So we did a land nav series you can check out if you're not familiar with some of the terms that we're using and techniques that we're using in this this video. The three things that we're going to try to do today is find a coordinates on the map, and then we're going to figure out between those two coordinates an azimuth or direction of travel and the distance it's going to take to get to that location. So in this particular scenario, we're looking for a hidden cache. This could be used for a safe house. This could be used for an escape route or escape line. This could be used for any number of different circumstances out in the field. But today we're just going to use a hidden buried cache as an example. So we've already been provided coordinates to the cache itself. So we can certainly use these coordinates and plot that in a GPS or on the computer to find this cache. But in some situations we might not have access to such a thing. We might not have a grid overlay to be able to do this or anything else. So if we just had our telemeter, we can find all of these locations. We can find and do plotting and planning outside of the field, or within the field itself. So let's get at it. So the first thing we're going to do is we're going to find the location of where we're at. And in this case, we've been driving down this road here, and we crossed a bridge, and we've parked in this position here. So what we want to find is our location first. And so to do that, we're going to use the scales on the side of this telemeter. Now it corresponds with a 1:24 scaled map. Now, luckily, we can use math to change the scale to any scale of map that we're using, as long as we stay in metric. We can technically change if we're not using, if we're using like a USGS map, for example, it's using 1:24. We can use some math to change that scale. However, it's much easier if you're sticking with something that's divisible to the 1:25. So, for example, to change a scale of the map that we're using today, which is a 1/50, we simply just multiply the figures by 2. If we're using a 1/25, it'd be by 10, and a 1/100, it'd be by 4. Okay, so that makes this scale functional on multiple different maps. So you don't just have, it's not just a scale for one specific map. This scale is not for one specific map scale. So if you're familiar with the grid overlays, it makes it easier because they have the scales already laid out, the main scales. But like I said, you can use math to provide a whole array of different scales. So in this case, what we're going to do is very similar to the grid overlay. We're going to use this measurement tool to measure our specific location within our coordinates. So in this case here, we've identified the grid that we're in, and so from here we're just going to measure the specific distances within that grid to get our full UTM. Now we don't have to use the absolute full UTM in this case, or in most cases. That's not necessary to use all of the numbers. In fact, we're going to be using within the thousands, and that's going to make the process and even the math a little bit simpler. So to find this location, we have our grid, and we're going to measure off our grid to find the location here, or the coordinates. And so to do that, we're just going to put 0 here on our location and measure out to the grid line, easting always first. So we're going to do easting and then northing. So in this case here, it's a 4. So we're at 4. Now, because we're at a map scale of 1 to 50, we just multiply that by 2, and so it's an 8. So our easting here, we look on our grid on the side, and we have a easting of 1418 east. And then we're going to go and do this again for our northing. So we're going to find the bottom or the southernmost grid line and measure our point from that line here, right? So we'll be working essentially out of this corner for a reminder. So from this corner here, here, and here. All right. So we're going to measure that, and that's a 1. Okay. So we're going to call that 2. All right. So it's twice the distance. So that gives us the coordinates again up here on the top of the margins. At the top or at the bottom of the map, we're going to have our coordinates, and so we'll plug that in to the grid coordinates, and that'll give us 162022 north. Okay, so now we have that location. Now, as I said before, we already have the location coordinates of our cache. So now we're going to find that specific location on the map. And so the coordinates here are 4154 east by 62008. All right, so we're going to find the grid square that we believe that cache is going to be in, or that we know the cache is in. So 6200 here, east, and then northing is 454, right? All right, so now we know that we're going to be looking in this particular grid, and then we can measure off from our easting. Now remember, we have to convert to the scale. So we can do that math simply in our head. And 454. All right, so it's somewhere along here, and then north to 8. So here's our 0.4. So here is our location for our grid, or for our cache site. So our cache is here, and we are here. Okay, so now what we can do is we can figure out the azimuth that we're going to be traveling, and then the distance between those two places, so we know how far that's going to be. Okay, so to do the azimuth, this is where the differences between azimuth and bearings oftentimes becomes misunderstood, because they're sometimes used synonymously because they are sometimes the same thing. But an azimuth, you can think of azimuth A for action. Azimuth is what you would travel. A bearing is any kind of measurement between 2 points, essentially. And so the azimuth is based on 360 degrees of the compass. So if we recall our compass, we have 360 degrees around the dial. A bearing, on the other hand, doesn't have to be limited to that, to the 360. A bearing you could be use milliradians. You can use all different measurements, essentially, to find the angle of difference between the 2 points. So in this case here, we're going to have to convert the bearing that we have here into a usable azimuth. And so to do that, we're going to use our telemeter. Okay, so the telemeter is going to give us on the shadow square the ability to find that direction of travel first. All right, and again, because it's a quadrant, right, so it's 1/4 of an entire circle, it doesn't represent the 360, so we're going to have to do a little conversion here. But essentially what we'll do is we're going to take the coordinates that we had just figured out, and we're going to subtract them from each other. All right, we're going to find the difference in those coordinates. So here we have our initial coordinates for our first point, and our second point here. We can just find, we'll write those out, which were, what was it, 4, 1, 4, 8 east by 6, 2, 0, 2, 2 north. All right, and so we'll just find the difference between those two, -6 and 14. Okay, and now we can take that and we're going to plot that on our shadow square. And so the shadow square here, using these increments along the sides, so this is our northing, this is our easting, okay, and where those two coordinates come together, all right, so 6 is here, so we can follow the dots right here, and I find it easier just to take a pencil and mark. Take a mark if you can, and then 14 is over here, and so we follow the coordinates down. Now you can use the string itself. You can use a piece of paper to do this, and you can wrap the string around the telemeter to line up the dots as well. If you're going to do that, I would suggest using some binder clips to bind the sides here. But I find it to be a little faster and easier just to visually do this, reference this, and then put a mark with your pencil on that location. So then we're going to take our string, all right, and we're going to run that over that dot that we just created on the telemeter, all right? And then that's going to correspond with the bearings that we need. And so in this case, it's 68. Oops. Yep, 68. All right. So then we simply just convert the 68, the bearing of 68, into a usable azimuth for our compass. And in this case, we're just going to add 90. If you are in the first quadrant, so north, between north and east, you'll just don't have to add anything. That's the first quadrant. If you're in the second quadrant, which is between east and south, then that's 90, which is where we're at. We're heading in that direction, that second quadrant. So if I use this as an example, this might help visualize it. So this is 90 here, so we add 90 in this, or 0 in this quadrant. The second quadrant here, 90 to 180. Then we'll add 90, and then 270 in this third quadrant, and then in this fourth quadrant, then 270. I'm sorry, 180 and then 270. Sorry, I'm getting ahead of myself. So you can always use the compass dial to help you remember what to add and what to subtract. But in this case, it's 90, so that gives us 158 degrees. So 158 degrees, we can set our compass to, and once we're at this bridge, and it'll take us directly to our cache. Now, the question then is, how far is that going to be? How far along is that going to take us? So we can use pace beads or to find the distance here, to find this location, or we could use timing, right? If we knew how fast we were going to be able to walk. And so in this case, it's very easy to find the distance with the telemeter. Obviously, you can measure this as the crow flies, or if you didn't have that map and compass in front of you, right, you can use your telemeter to do that. And so in this case here, we're going to put the string back to where we had it, right here, and that was at 68, remember? All right, and then we're going to move our marker, this little piece of ribbon, to that 68, and we're going to bring that up, move that right up the scale here, and that is comes to be at 0.53, or 53 rather, so that's 0.53 kilometers. So 0.53 kilometers is 530 meters. So we know now that if we head in 158 degrees for 53 meters, so we could mark that out with our pace beads, or we could, again, we could use timing if we knew our distance to travel, our timing of travel, that we would get to this point. Now, if this was an area that we could visually see this, then we could use our telemeter then to range find. So we could use the telemeter then to find the exact location that we're heading to, if we could potentially see that. Or as we get closer, we could see the range. So we could use the telemeter range finding capability, which we've showed in other videos, to find exactly the location. All right, so maybe we're in a city and there's different buildings. We could, or telephone poles in the area, haystacks, trucks, whatever we know of something of a height, a known height, we can then range find to find that specific location and get a visual on it. So yeah, so that's essentially how to find your coordinates, how to find distance, and a usable azimuth with the Winston telemeter.